deck. There we go. Cool.
Yeah, that is good. All right. Take it away.
Righty. So I'm going to talk about a design pattern for SwiftUI that I've called the router pattern. And this helps me manage a level of complexity myself, to be honest with you, inside of the apps that I'm working on and building. Quick introduction. My name's David Wood. I'm based in New Zealand. I've been here about 4.5 years. Previously in the UK. I've had apps in the App Store for a few years now, since 2015. And I'm currently a coach, an iOS development coach. And what that means is that the company that I work for, Snapper, I look after whoever's doing iOS development. If they get stuck on anything, I jump in and help them. I also am responsible for the architecture of the apps, the way that we develop anything iOS. So I tend to spearhead any new projects, and we do have a few. Snapper is a bus ticketing company. And what we do is we've got NFC-based cards that everybody in Wellington uses to use the bus, and similar to the Oyster card in London. And we have iOS and Android apps to top up for those. And we also have a bunch of similar stuff in Ireland for a company called the NTA. And the new apps I've referred to as well are all around transportation. We've got apps for accompanying drivers when they're doing new routes and things like that. So all about transportation, all about buses. I also have a fortnightly iOS podcast called Waiting for Review. Yeah, and as you probably gathered, I do indie app development as well as my day job. So I tend to have no life outside of iOS, to be honest. Moving on to the next bit. So another design pattern. Yeah, okay, there's loads. You go searching, you'll find MVVM, Viper, usually all around UIKit, to be honest, a lot of these things. And I know we've got TCA over for SwiftUI as well. But when I was looking over this last year, what I didn't find was something that really fit the requirements that I have specifically within the team that I support. So I want a design pattern that is easy. I'm training a lot of interns. We have an intake just a few months ago of 10 interns to the company that are going to dip in and out of iOS development as the year goes on. I don't want to have to spend 2 weeks getting them up to speed on the architecture. So, it's got to be fairly easy. Then the other goals for the design pattern are pretty obvious, to be honest. Divisible, yep. I mean, you want to be able to say, I'm working on this screen or this part of this area in the app, and not tread on any other developers. We're working as a team. We tend to have sometimes up to 3-4 devs working on a project on a specific app, depending on what's going on. And it also needs to be flexible. We hit the usual issue, or I want to say issue, but we hit the usual flexibility that gets required where design get a bright idea or we get some UX feedback, and instead of burying that screen inside of the accounts page, for example, we might want to pull it all the way up and sit it in the tab bar of the app. So we don't want to spend 2-3 weeks refactoring everything just to sort of pull everything apart or whatever to make it work. It's got to be super easy to move things about. And one of the other goals is that it needs to enable testability, specifically unit testing across core business logic. And I'll touch on that in a bit. Now, SwiftUI, to be honest, all the example code out there, stuff from Apple, tends to push a tightly coupled navigation, and dependencies are pushed through the view layer. Data is pushed through the view layer from one view to another quite often in all the examples. And it kind of runs against some of these goals in some ways for me. So, again, as we get into a bit more of this becomes obvious. But so SwiftUI pushes us towards using view models quite often. You'll build up a bunch of state or whatever. It starts to make sense to shove it into a view model object and do something about that. And if that view model has an external dependency, because of the way things tend to go, the view itself has to give that dependency to the view model. You end up in a pattern where the view model is instantiated inside of the view, held as a state object, for example, and then whatever it give me 1 second, whatever it needs to talk to ends up being brought out of the environment by the view and then given to it in on a peer or something like that. And that again sort of runs against the goals that I have for this. That's not going in the direction I want it to go. Navigation is another problem. We've got navigation links, we've got tab views, but views are now responsible for the UI on the screen, they're responsible for the flow, they're responsible for managing data. That view's got a lot of responsibilities going on. Pretty top heavy. So previous life actually, in the company that I worked at before the one I'm at now, we use a lot of coordinators for UI kit. And if anybody's come across a coordinator pattern, I think at its best, what it does is it means that you're able to treat view controllers and any associated view model as modules. And you can pass them around between coordinators, and the coordinator manages the flow itself. So we create this kind of this object that is doing a lot of what things like storyboards would do for us, but it also gives us an insertion point to pass services to things like view models. And it splits the code base up, and it means that you can kind of say, okay, I'm working on this screen, you're on that screen, off we go. Now then, I thought, can I do this for SwiftUI? So enter the router pattern. I sat down with a whiteboard and kind of holed myself up in a room over a weekend. Lots of coffee, lots of test projects, like scribbling stuff out, just getting ideas out and actually just testing it in Xcode and thinking, okay, can I do something that lets me achieve this sort of separation? And along the way, actually, I figured that coordinator as a name wasn't going to cut it, because when we wrap UI kit, when we wrap UI view controllers, quite often we end up with a coordinator object inside of there as well, doing its own thing. So I thought, okay, we need a new name, hence router. Now, going over the flow, this is what I came up with. So we've got global services and managers that can be shared between any part of the app, and they are shared to the view model via the router. So this is our basic kind of dependency injection. I'm not using any special library or anything to manage that. No property wrappers in the environment or anything like that. We've just got the first router gets given these services, and then whenever they create anything after that, they flow down from there. So pretty straightforward, to be honest. Now, the first router will be, for example, an app router. It will do whatever we need to do to sort of start the app going. And the router has a responsibility for creating screens. So, and here a screen is representing the entire view of the screen. It's effectively like a view controller. And a screen is paired with a view model. A screen can also create other SwiftUI views as well inside of it. So we do have some classic SwiftUI views that don't have view models. And they will tend to be like little molecules and atoms that make up the design of the app. One thing to note here is for navigation, the screen itself can signal back through a protocol. I don't actually tend to call it delegate when we get down to the code, but it's kind of that sort of thing. And it can signal back to its router. Now, the reason I use a protocol there is so that the screen can actually be associated with any router. It's sort of agnostic of who it's talking to. If a user interacts with anything on the screen, presses a button, does anything like that, then that goes back to the view model. And the view model can then, depending on your business logic, will either mutate some state inside of itself that will trigger a change on the screen, or send something back to the global service or manager. So, for example, we might search for something, it might talk to an API. The API service then may deliver data back to the view model. It'll update something locally, and our screen updates from that. So that's the general flow of things. Now, going over the responsibilities, I've talked to some of these already. The router has a responsibility for creating our screens and view models. Anything like a navigation view or tab view tends to live inside of the router's view. A router will have its own view, but it is very basic. It's just used as a jumping off point for the screens to be created from. And a router can also react to any global state that's changing to change the screen flow. So, for example, our app router might keep track of whether we're logged in or not, and update whether we're showing the main screen of the app or the login page. And a router, if we're talking about something, say for example, I had an onboarding flow that's represented by an onboarding router. I might have local state inside of that router to sort of say, okay, what screen am I showing in that series of onboarding steps? Where am I at? So I might manage that from there, or we might have something like a terms and conditions flow where we actually keep track of whether the users tick things or not along the way. So the router can hold some local state too. Another responsibility of the router is that it's able to create child routers. So you can sort of see everything. It's routers all the way down for flow. Now, the view model itself is responsible for carrying state for the view. So anything that's published inside of this observable object view model, the view will bind to and use for representing state on the screen. So the view model will carry that. It's responsible, as I mentioned, for sending data back to any global services or dependencies. And just fast forwarding through to the screen, obviously we've talked about that holds the UI for the entire screen and has these other responsibilities for data and for talking back to the router for flow. And the classic SwiftUI view, it can receive bindings or maintain its own internal state if we need it to. So the screen can give it something from the view model, for example. But honestly, I tend not to do that. This tends to be a dead end where it's literally just receiving like a string or an image or something like that. And it's reused all over the app. I would use this for like components that we want to see again and again. So let's see if this works, because a code demo is always fun. Righty. So if I just move over to Xcode, you'll see that I've got an app. And we've got a simple tab view. We've got here so we instantiate an app router view, and we give it inline the app router and app services. I'm just going to go through to the app services because I think they'll illuminate what I mean by my global services and how I've laid them out. So I've got a protocol that defines everything that's global to the app, and I've got a bunch of managers sat inside of those, and each of these are protocols as well. And then I've got the real definition here, hence app services, and then I have a mock version here. And that becomes important for unit testing the view models later on. So you'll see in a moment when the router creates a view model, it gives it this global services class at initialization, and that means every view model gets access to all of these. I'm not being specific about whether a view model needs this service or that service or any other service. They get a services object to talk to, and everything hangs inside of that. Remember my first point, the design pattern has to be easy, and it has to accommodate interns and juniors as well. So I don't want them getting too stuck on what they're importing, how they're importing it. Everything's just there, it's available, but it's passed through this structure. Now, if we take a quick look at the login manager, what I tend to have is, this is its protocol that defines it, but I tend to carry a state object inside of there that's an observable object, and it'll have something published on there. And what that means is that we can talk to this app manager's state, we can bind to it in our view models, and we can update based on what these published variables are doing. But this is global. So any screen in the app through its view model can access this information. Any router can access this information as well. So if we take a look at the app router, you'll see that we set up, and when we set up, I look for whether we're logged in or not, and I'll switch this screening on based on tab or login. I'm currently logged in, so there we go. And this app router view, it's literally just switching at the moment over that value in the router. So yeah, when we're logged in, this value is set to true on this global login manager state. That then provides the mechanism locally for which screen we're at, and the app router will toggle accordingly. If I log out, Again, that's just changed. If I log in, this is all fake. It's not really doing anything, but yeah, there we go. We've now toggled that and we're in. So that's kind of the top link of the diagram I showed you on the slides before, where the dependencies come down and enter the router, and then they get given by the router to the view model that is backing the screens, and also to each router itself. So what we're going to do as a quick demo is I'm going to take you through adding something into the structure. So I'm just going to uncomment this here. And so we'll get going, and we have this structure in the router's view. It's talking to the router itself, to this view builder function to get a list. And off we go. This should be pretty straightforward. So there we go. We've now got that there. That's just a text. So let's do something a bit better. So what I'm going to do is just take that one out and add this one in. And then, yeah, what else? The first, yeah, that's going to want me to just add these two as well. Okay, so what we've got here now is we've got a list. And the tab router in the one that we're actually using, is this function has now changed. So we've got a screen is being instantiated. It's being given a router. That's that kind of protocol delegate callback that I mentioned before. And it's being given a view model with the global services contained inside of it. And down here, we extend our tab router to be that, so that it can receive anything back from the list screen itself. And you'll see right now, the list screen's just got an empty protocol there to define it. It has this maintained here, and if we need it, it's there. So I've actually got templates that stub all this out for me as well. And in the example repo, I've even got a script that goes and installs them into your Xcode templates folder. So there's something there that can be taken a look at if you want. But this is an embryonic screen. And you'll see here it's connected to a view model. And that view model, when it instantiates, we're receiving the services. So that's coming from the router. That means we've got access to all of these global objects. And this create rows, rather than responding to any published data, I've just very simply set it up to go and get data from this data manager and to create our list rows based on what it receives. But you can imagine that might be calling an API, for example. So where can we go from here? Well, it'd be nice if we could click these things, right? And that would actually show us a bit of the navigation flow inside of the router pattern. So what I'm going to do, I'm just going to take that one out. And we're going to go to version 3. And that also means I need to bring this one in and take that one out. So let's look at the screen first. Here, we've got a function in the router protocol that says, okay, we're going to go to the list detail. And now I've changed this so that these are buttons. And when you press it, we're going to signal to the router. Okay, I want to show the detail, and I'm actually passing some data back here. We might be picky about how we do this, but it shows the demo pretty well. You know, for example, if that selection was considered to be global state, then we would probably just talk to the view model and signal back to something globally, and then have the router respond to that. That's how our login button works in this pattern. But here I'm passing this data back for now, just to show the example. So if we go to our list router that is just here, this is what the screen is now talking to. And actually, it's important for me to say this has now changed here in the tab router as well. Before, we had it talking to itself to create the list, and we had a function inside of the old router that was creating the list screen. Now we're creating the list router because we've got some flow on the go. I've probably forgotten to pull something in. 1 second. Yeah. Okay, there we go. So now the tab router itself for this, instead of building the screen itself, it's actually instantiating a child router. That's what's going on here. And again, it can create it. It's creating a router object and giving it to it in line, and it's giving it these global services. So that's the router's responsibility of passing these things along the line. But that nicely replaces what we had going on there where we were generating the screen before. In the old version we had that. So now we're using a router, and I'm going to go over the list router and how it works. So this is the same as we had before to just create the screen. That's great. I was literally able to copy and paste that function out of the other router when I was building this demo up. This provides the detail when we click it. So it's going to return just a text view with the description of the selected row. And we've got a Boolean up here as well to say we're going to present that detail. Down in our list router view, the structure's like this. We have a navigation for the entirety of what's going on in this tab. And then in there, I've got a Z stack, and I have the list at the top. But behind it, I've got this navigation link with an empty view inside of it. And it activates based on that Boolean we mentioned before. When it's active, this is the destination it's going to show. So when I tap on one of these, it signals back to its router. This function gets called. We cache, store the row that we've selected in the router itself. And then we also toggle the Boolean. So, okay, let's present it. And then this kicks in and off it goes. So if I run this, you'll see there, okay, there we go. We've got that. And we come back and we can click any of these as well. And this is getting triggered every time from there. So that's its signal. And yeah, we're coming back from the button there via that route. So that kind of summarizes setting up a screen. You know, the router creates a screen, it creates the view model, it gives it these global services. And then when we want to change where we are in the flow or the navigation, that screen should signal back to its router and say, okay, now we need to do something. We're going to go somewhere. You know, we could have modal versions of this, and this could hit a dismiss, for example, and then that would toggle that off back in the router. So that's the general sort of flow of this. And you'll see that it kind of lets us compose apps out of these screens and these view model pairings quite quickly. You know, if I want to move that around now, or if I want to surface that list inside of here, for example, then it's as simple. In this case, we've got a help router that's on the go there. And I could very, very simply just take this that creates the router view itself with that flow inside of it with the navigation. And in the help router, I could bring that in here. And we probably would take pretty much all of this out, actually, because I don't want to have two navigation views in the stack. But what I can do very quickly is just have that there. And because the list is self-contained inside of its own router, that was dead easy to just drop that in there. And we've got the navigation going on and everything else as well. It's encapsulated and reusable. So yeah, that's broadly the dev demo. To be honest with you, I think I'll come back to the slides. Yeah, so to round up, I've talked to most of these points along the way. There's a bit of to me to you that sort of goes on with this. So it tends to be that the view models are providing local state for each screen, and they're kind of decanting any global state that is needed. So you end up quite often with the data's in the global manager, but it's also echoed in published variables local inside of the view model. So there can be a bit of duplication. And I tend to try and keep things decoupled like that, because it tends to create a situation where the separation is nice and clear, and it lets us do different things. You know, we'll build up that data model to represent a list, for example, based on how the view needs to look, not necessarily on how the data comes back from a service. So you will get a lot of that sort of local state but depending on global state. And the view model does that job of bridging the gap between the two. We've seen that screens and view model pairs can be moved between routers easily, and actually routers can be moved between other routers fairly easily. So that's cool. That's achieved that sort of flexibility I mentioned at the start. But the beauty of this is largely the screens themselves are just SwiftUI views. I'm trying very much not to use too much sort of secret source, property wrappers, funky little things that you're going to have to stay up all night learning. The idea here is that if Apple decide to do something of their own for managing flow between different screens, then hopefully I can rip this out, move on in life, and forget all about it. I don't think that's going to be the case, but that I don't want a pattern that's going to be an absolute complete rewrite of everything if there is a paradigm push by Apple. And that's part of what this tries to achieve as well. Yeah, I think I could get into unit testing a little bit. I've put a note here for that. One of the things that you'll have seen when I discussed at the beginning, each manager is defined by a protocol. They can all be mocked. So at the view model level, if we come back to this view model here, where it's talking to that data manager, if I want to test this, I can just give it the mock version of the services. And if we actually look in our data manager and look at what its mock implementation is at the moment, I tend to build them like this, where I'll have a variable to say, has a function been called? And we'll tick that off when it's been called. And if it's returning something, I tend to provide an override to be able to return a given set of test data back. Now, in my unit test, we can get this down to, I'll create a mock services object. It's already got this mock data manager inside of it. And I can write tests very quickly by going, okay, I'm going to instantiate the view model on its own. I'm going to give it that mock services. And then I'm going to test, for example, in this one, I will test that when I've created it, that the get data in the mock data manager that I've given it gets called. And then I'll iterate and have other versions that check that my rows get created correctly with a given set of test data and that sort of thing as well. So this is set up from the beginning to allow every view model to be unit tested. We don't necessarily as a team go all the way down the path of testing absolutely everything, but as a given rule, anything to do with data setup gets tested, and any public functions inside of the view model that the screen itself will talk to, like when a button is pressed, they'll get tested as well, because they usually mutate a state that we can test. So that tends to be the flow, is that we'll build things out, we'll build a screen up and get a feature ready, and then as a team, there'll be another task to go and create these tests, and this pattern gives us that sort of out of the box, so we can get tests going quite quickly. Hi there, Kai. I see your hand up. Oh, all good. Cool. So I think, yeah, that brings me to the end. Any questions?
Awesome. Thank you so much, Dave. Yeah, Kai just waved
cool.
to someone dropping off.
All good, all good.
Yeah, thank you so much. That was really interesting. I think just it's a very common question I get when talking about SwiftUI. People do wonder how you can separate the navigational flow and use something like the coordinator pattern. So that's awesome to hear your approach.
Yeah,
I think sorry, you go.
No, go for it. I just noticed there was a couple of raised hands.
Yes, that's what I was gonna say as well. I think yes, Ed, you raised your hand. I think someone else said in the chat as well that they had some questions, but let's start with Ed.
Yeah, I was wondering when sort of the history and how this kind of came together as far as this pattern. How heavily was it influenced by the current version of Swift?
Yeah, reasonably. So lineage-wise, I came up with this about May last year. So we were in iOS 14. And the project that this was going to get used at the company I'm at was able to support iOS 14 straight away. And then we had a couple of edges with it, actually. The view models themselves initially were set up as observable objects, and things kind of fell apart there. actually state object has been needed, and that's part of the reason for creating them in line with the screens themselves as well, is to actually give them to SwiftUI's memory management, so they live properly with the screens and views themselves. But what happened is that the apps themselves that we were developing weren't released until after last September. So everything kind of came together with iOS 15. So this is very much an iOS 15 pattern for us. Does that answer your question, Ed?
Yeah, I think so. And I'm just looking forward. I know everyone's kind of focused on concurrency these days, but I know it's still an evolving language, and Apple's adding their own sauce to it as they see fit. Yeah. Do you anticipate that maybe we'll see something in DubDub that tries to mitigate some of the hardships of this coordination?
I don't know. I was hopeful last year, to be honest. When I put the pattern together in May, part of the reason I have the note about saying I want to replace it as soon as I can was actually a hope when I made my blog post last year, sort of around May time. That didn't eventuate with DubDub, so we'll see. It would be nice. It'd be very nice. One of the things I think people feel we've lost with storyboards is a lack of anything Apple to really manage that flow in navigation. Yeah. So yeah, if it comes along, hopefully we can use it. Sorry, go on.
No, that made me curious. Out of like, if Apple would introduce something, what part of your implementation is it that you?
Are you cutting the line?
Yes.
Tim was raising his hand.
Just because I was just curious, like, what is your wish list item that your solution doesn't have that you would hope that Apple could do?
Yeah, I'm not sure. I think it would be something that is sitting between a view and an observable object that kind of is able to take away that data side of things a little bit, like the transmission of dependencies. I know we have the environment, but it's not really that useful all the time for some of these areas. And something that can represent the navigational flow itself as well. As it is, we probably wouldn't rip it out on day one if something comes along like that, but we would, as a company and as a team, would be looking to move to it pretty aggressively. Yeah. Because I don't particularly like stepping so far out of the box if I can avoid it.
Okay.
All right, back to people that follow the rules. Tim.
Hi, I was curious if you thought about like deep linking and what your story is around that, because I think that's pretty common that people want to link to like a specific tab or maybe a specific view. Maybe that router pattern solves that. I don't know.
It could certainly enable it, right? Because you've got an object that can receive some level of global state and kind of respond to that and put itself in the right configuration for it. I don't think the pattern directly solves the issue. And actually, that's one of the things we've been talking about as a team, is for a next iteration of the pattern, deep linking would be something we'd try and attack and solve. At the moment, none of the apps we've got that are in this pattern are using deep linking, but they may do in the future. So that is sort of on my horizon to figure out. I don't know exactly how I'm going to do it. We will probably come up with some sort of deep linking representation, like some sort of object to represent that. That can then be passed through the router structure itself, and they can all respond appropriately or not. But it's going to feel quite manual, I think, with this pattern. I think other patterns like TCA probably solve it a bit more elegantly, to be honest with you.
Cool. Also in the chat, Casey said that they had some questions.
Yeah. So when I was looking at the diagram they pulled up, so this is my understanding of your router, is that it serves as like the centralized state that the rest of the parts of the app like send their changes to, and then they can respond to those changes. Did I get that right?
Kinda. So let's see if I can just pull it quickly back together. The router's really just housing those global managers inside of the services itself, and then using it when it instantiates screens and view models. It can hold some of its own local state for navigating between different screens.
Where do you hold your global state?
In this services structure.
Okay.
And yeah. Yeah, so from a code point of view, that's this.
So
sorry, go on.
Oh, so like when I was looking at the diagram, my first thought was this looks very similar to Redux, where you like send all your changes to one place and then those changes get spread out everywhere, or yeah. So I was thinking like so there's something called re-Swift, and that's what I use for like this central app state sort of thing.
Yep.
But I don't know how that really compares to your router. I wasn't really sure. Like, how would you say, what's the difference between your router and Redux?
That's a good question. I think that with Redux, you're clearly, the implementations I've seen tend to pass that global state data down through the view layer again. So it tends to be that there's that concept of global state living inside of the environment, and then the structure's responding to it all the way down. I think this decouples it a little bit more, simply because there is global state, but the router itself is what responds to that global state and makes decisions from it. But yeah, conceptually, there's probably quite a lot of similarities, to be honest with you.
Okay. And then really quick. So you said you were using SwiftUI, right? And you were also using UIKit wherever SwiftUI would fall short. So like, and based on how you talked about SwiftUI, it seems like it was giving you a lot of trouble in the beginning when you were like thinking about this.
No, not at all. SwiftUI wasn't giving us trouble as much as I knew that there were the other requirements that I wanted to solve. I wanted to make sure we were unit testing quite well across the view model logic. And yeah, I also didn't want to end up with an app that had lots and lots of views that was sort of codependent on each other for flow.
Okay. All right. Never mind.
Yeah.
Thanks.
Cool. But no, it's fair to say that SwiftUI doesn't give us everything, so we do still have to wrap, UIKit views here or there. Not so much with iOS 15 though.
Right, Jules,
cool.
You also have your hand up.
Thanks. Hello. What kind of coverage do you get with this testing methodology, and how long do your tests take?
Good question. Yeah, so I mean, it's all relative. And if I think about the main app that we've got in production with this, which is a 3-tabbed base app that then has like a couple of screens on each tab, and then eventually it initiates a modal that comes up that has a couple of different states inside of itself. For that one, we've got about probably between 90 and 97% across all of the view model logic, and across all of the global manager logic as well. Because the other thing is the global managers themselves are nicely dumb, as it were, and able to be mocked for any dependencies they have. It's a distinction I didn't talk about here, but a manager can receive multiple services as dependencies, but a service is a dead end and can't receive anything else as a dependency in this structure. So that's an internal linguistic that we've got. A service is a dead end. It's a thing in its own right, but a manager can receive multiple services to do what it does. As for instance, we might have a manager that calls an API, but also saves something to the keychain after the user's been logged in. And so the key change service is one of those dead ends. But across the view models, we've got in the high 90s. Across the managers, we've probably got closer to somewhere between 80 and 90. In terms of how long the tests take to run, the unit tests are really quick. We've got getting on for well over 100 unit tests inside of this project, and they're executing inside of like 15, 20 seconds, because they're just small little things that are testing on and offs and signals through functions. But we have UI tests as well. And that's something I've not talked about inside of this presentation. I've got a whole other setup for how we approach UI tests, where each screen has what we call a screen object to represent it. And that screen object will have references to what makes up the screen in terms of labels and buttons and that sort of thing. And we reuse those for navigating our way through in UI tests. And it means that we can get our UI tests down to 3-5 lines of code each time because we've got all this sort of screen object structure to go and handle all the boilerplate behind the scenes. So we've got UI tests for pretty much every screen as well, and they take about 45 minutes to run. Yeah.
Cool.
But we've got all that sat on Bitrise.
Oh yeah, do pretty good service.
Yeah. Yep.
Cool.
Yeah.
Cool.
Thank you so much once again, and a big round of applause for you again.
Oh, last minute hand.
Yeah, I just wanted to ask you. You said that you had a project and some scripts to actually add some of these templates in Xcode. How can we get a hold of that?
Yeah, so I'll link it in the chat as well. But I've got on my GitHub, I've got David Gary Wood over there, and SwiftUI Router is one of the few public repos that are available. In there, I've got this symlinking for the templates. So if you check it out, the symlink itself will link in this folder here into the appropriate place inside of your library. Take a look at the script itself if you want to see that location. Certainly wouldn't advise anybody to just run a shell script without checking it out first from a random repo. But that does it. And then after doing that, Xcode picks them up. So in Xcode, if I want to create a new router, for example, I can just hit it up and got that there. We'll give this, I don't know. Can't remember whether I have included router in the template or not, so this might be something router. But forgiving that, yeah, so that goes off and that has all of this boilerplate for being an observable object, some marks here for everything. We're assuming services is our God object with everything, and then the router view here is where we'll then call inside of itself to instantiate screens. So I've got templates for those. I've got templates for the screen and view model pairs as well. So that makes life a lot easier. Again, having a team quite often structured with juniors and interns, it's been really nice to say, you want to get started? Check out our main base repo, run the shell script. You've now got the templates. You off you go. You're cooking. So we've got all that sort of set up for them. And then this is my own version for demonstrating things. And for my indie apps as well, I've got, again, my own version of these. So it just makes life a bit easier.
Awesome.
Yeah.
Thank you.
I pasted the link in the chat as well.
All right.
Cool.
Awesome.